Hello, we are back again. Today, I'd like us to talk about the CPUs, the PCH, and the GPUs. How do you test, if I may ask? How do you know that the CPU is dead, or the PCH is dead, or the GPU is dead? I know sometimes we find ourselves in a very strange position to declare the motherboard is beyond repair. The only time where we can say the motherboard is dead is when you have the CPU or the PCH shorted. Or sometimes you find that the onboard RAMs, for example, these are the onboard RAMs, these are the NAND chips for the memory. Sometimes you find that they are shorted, the RAM is shorted, yet you don't have the spare parts to replace it, or you consider the amount of work you need to do, you need to repair that motherboard is too much, or the cost of it is too much until if you compare the cost of repair and the cost of buying a new motherboard is almost the same, you will consider that beyond repair because the amount you will charge to repair that motherboard is the same as buying a new one. Nonetheless, that motherboard has onboard SSD and you need to retrieve the data for the customer. That is when you can try to repair. But most of the time, we declare motherboard dead because the CPU, the PCH, or the GPU is shorted. And getting another CPU, installing it is also very expensive. Very expensive in terms of skills which is needed, time which is needed, risk which you're taking. And again, once you replace the CPU, it's not guaranteed that after you replace it, it will work permanently forever. Sometimes you replace the CPU, then within less than a month or few months later, the CPU shows that it's no longer working. Yet you charge a lot of money, so the customer will not be happy, and he or she will blame you actually. So as a good technician, you should know when not to repair and what to repair at what cost. So today I'm going to discuss with you how to test the CPU when it is faulty and how to conclude that the CPU is dead, the PC is dead, the GPU is dead. Here with me, I have several motherboards. We are going to start with one of them. Let's say this one. Let's start with this one. Every laptop motherboard must have the CPU. The CPU is the brain. Let's say basically it's the brain of the motherboard or the brain of the laptop because all the activities, all the processes happens here. I know if we can use an analogy of a human being or any animal, when you say somebody is brain dead, it means that person is dead. It's only that it has some parts of the body which are working. And the only thing remaining for that person, the usefulness of that is to do what's called the organ donation. So same case with the laptop motherboards. When the CPU is dead, the only thing remaining for that motherboard is for it to donate some other parts, some other components, like the charging IC, the MOSFETs, the capacitors, the ports, the HDMI ports, the diodes, the connectors. Same case with the human being. When it is brain death, it's time for that person to donate the organs like lungs, the kidneys, and all those. Of course, with the permission of the family or the owner or the loved ones. So same case with the motherboards. If the motherboards are brain dead, the CPU is dead, you'll have to ask permission from the owner to allow you to use that motherboard to repair another motherboard, maybe to fix his other motherboard, or you can't even buy it. You can buy that motherboard from the customer. It's good to explain to the customer this laptop is beyond repair, and I'll suggest you might leave it with me so that I can pay you this, or I will give you this discount to this motherboard. It is business. So you have to understand each other. You cannot just remove a component because that motherboard is dead without the permission from the owner. So the CPU is this chip. It has a CPU here. This is the CPU. And then it has another chipset within the main chipset. This one is what's called the PCH. PCH is platform control hub. This one inside this PCH, we have other two sub chipsets like the south bridge and the north bridge. The north bridge is a chipset found inside this smaller chipset, that is the PCH. So the PCH is the bigger one. Then inside that PCH, we have the north bridge and the south bridge. The north bridge, or sometimes called the memory control hub, is a chipset which is responsible for ensuring the communication between this CPU and the RAM, whichever the RAM, be it the onboard RAM or be it the removable RAM. So what controls the communication between this one and the memory is what's called the memory control hub, or in other words, called the NOT bridge, which is inside this chipset. Again, inside here, we have what's called the south bridge. The south bridge is a chipset which is responsible for controlling all the input devices. That's why some other time it is called the input control hub, because it is responsible for controlling any plugged in component like the battery, the keyboard, the HDMI, the USB, the Type C, the data transfer, the SSD, all those. So the responsibility for the south bridge is to control all those, including the speakers, the fan. So that's why most of the time we find this chipset getting shorted, this smaller one getting shorted. Why? Because sometimes you plug in an object which is having a short. Let's say you have a flash or you have external keyboard or whatever you plugged in, even the audio jack. Maybe you plug in an audio jack which is having some issues. Whatever you plugged in, it will be controlled by a sound bridge, which is found inside here. So sometimes whatever the device you plugged in, if it is having a short, that short is sent directly to the sound bridge. And then to find that if it was shorted, if that whatever you plugged in was having an issue and it short and create the short with these pods, it is sent directly to the sound bridge inside here. And that would be the end of that motherboard. That is why most of the time I find the guesses like that, especially with the laptops which belongs to the DJs. Yes, the DJs most of the time are the victim for this, because you find a DJ maybe is playing in an event, and then she plugged in another device which is so big, which draws a lot of power, maybe big speakers, other big devices, or even sometimes you find it plugged in an extension or a dock station. A good example is a dock station. With this motherboard, this one I have the dock station here. So this is what's called the dock station. This station, you can plug in another device which is an extra port. So you find a DJ plugging in a dock station here, a component here, then that device, it will be used to charge other devices. You know, this motherboard syntax in 19 voltage. So you find somebody extending this port, then you will use these extra ports to charge other things like other phones. So many phones. You know, the more phones you have, the more power will be needed to throw a lot of power. So having in mind, this port is controlled by the sound bridge, which is inside here. So in case there is a power surge somewhere, and then this dock station experience some surge, that surge is sent directly to the sound bridge, and then it kills the sound bridge, and it will be the end of that motherboard. So I have explained most of the things which makes your laptop to die. Another thing, maybe you plug in a RAM. Let's say you have this removable RAM. I think I have one here. Let me show you. So here is the PC4. This is the PC4 for this machine. So when you plug in the RAM, when you insert the RAM, you will insert this way. You see? So some other people, not only RAM, let's say also you have an SSD. SSD is inserted here, and then you have to screw it here this way. So sometimes you find somebody accidentally, knowingly or unknowingly, remove the SSD from the laptop when the laptop is on. I have also received a lot of cases like that. The customer comes in and reports the laptop dies because I forgot to remove SSD, or I removed the RAM when the laptop was still on. You know, sometimes while removing the SSD, it is not recommended. When you want to plug out any component, especially the RAM and the SSD, make sure your laptop is off. If possible, disconnect all the power source in the motherboard, because sometimes while removing this SSD, you find that it is stuck. Then you do this, you do this way. You know, the more you're doing this, these terminals touches the other side. Maybe you find that as a terminal touch the wrong terminal, and then it creates a short. Because among these terminals, there are the terminals that are responsible for power transmission or power conduction to the chipsets here. There are other terminals which are responsible for data. Same case applies to the RAM. Those the RAM. Among these terminals for the RAMs, you can see we have so many of them. Can you see them? So those terminals, there are some terminals which are responsible for power, operating voltages for the RAM. There are others which are carrying terminating voltages for the RAM. And among these terminals also, there are also some which are responsible for data. If during the removal of your RAM and the laptop is on, and then you remove this way wrongly, then you find the power terminals connect to the signal terminals, then you'll find that a short is created. And that short, once created, it is sent directly where? To the node bridge. That's why most of the time, this smaller chipset is the one which gets shorted. So you find that the short is then directly to the node bridge, which is inside here, and then the laptop dies. And there's nothing you can do. Once it is the issue to do with the CPU, there's nothing you can do about that. You will have to buy a new motherboard, and then we call it business. This one doesn't always get shorted. They don't always get shorted, but this one is always defective. So this latest series of laptops, you find that they combine the two chipsets within one main chipset with older generation motherboard. I wish I had one. I don't have one in my bench anywhere. With the older generation laptops, you find that they used to have a CPU here, and then this PCH, it was placed somewhere away from the CPU. It was somewhere. With the older ones, other than that, let's say generation one, the older one, I can say the whole school laptops, they used to have not bridge chipsets, the solid bridge chipsets, and then the CPU. They used to have like three chipsets. And of course, if it is supposed to have the GPU also, it will have another chipset for the GPU. Then they combined the two. So from the node bridge and the south bridge, they combined two of them to come up with the PCH. So they came up with the PCH and the CPU. Then you have the GPU somewhere. Then after some years, they also came up with something different. They decided to shrink the chipsets. Then they put the PCH instead the CPU. Then they came up with one what? They came up with one chipset that is this one now, which is the CPU and the PCH. So with this one, this is like a trap because you find that this one is always the one which gets shorted. The other one, which used to have the not bridge and the salt bridge, you could find maybe not bridge is shorted if the issue was from the RAM or from the SSD, or maybe the salt bridge was the issue if the short came from the USBs or the audio jacks. Now, and all those, even though they used to have separate not bridge and the salt bridge, still, if one of the chipsets was having an issue, there was nothing could be done because still a chipset. And when dealing with the chipset, survival, the survival probability is low, very low. That is why instead of wasting time trying to repair that, we just have to focus on something else. Having discussed a lot of things, you can see all these motherboards have the CPU and the PCH. And we say the PCH contains the north bridge and the south bridge. And I believe by now you know what is the meaning, what is the work of the PCH. PCH is the platform control hub. It is a platform controller. And then you have the north bridge and the south bridge. North bridge is the MCH, and the south bridge is the ICH. ICH is the input control hub, and the MCH is the memory control hub. Then we have other CPUs like this one. So this is an AMD CPU. This one contains everything within it. Because the PCH inside, the MCH inside, the ICH inside, the CPU itself inside. This is a AMD processor. This is an AMD processor. And then there's something also I would like to mention. Within this chipset, these are the Intel CPUs. So within this Intel CPU, inside it also have the GPU. In my other videos, there was a video whereby I talked about the GPUs. Whereby we said we have two types of the GPUs. We have the dedicated GPU, and then we have integrated GPU, whereby we say integrated GPU is a GPU which is integrated within this Intel CPU. So uh, CPU, inside this CPU, we could have integrated GPU. Maybe the only thing which could make this laptop to this CPU to get faulty or to get shorted is the RAM, the memory. Because within the memory, when you have an issue with the RAM, that RAM creates a short, which by if you're not lucky, the short went into the CPU. So sometimes you find that short went directly to the GPU. So each idea we have micro components which are having for the GPU. So in case that issue went directly to the GPU, that is the only time whereby you can find this CPU is faulty or is shorted. Yes, it applies with all other ones. So in case a laptop doesn't have the dedicated GPU, it will have integrated GPU. I know you're wondering what is the dedicated GPU. Dedicated GPU, I believe I said integrated is found inside here, inside the Intel CPU. Dedicated, if this laptop was a setbook, for example, you find most of the setbook for this model have the GPUs here. So you could see this motherboard, it was meant to have the GPU. You can see this place. Yes. However, whoever was planting this component, so it wasn't necessary to put the GPU. But some other motherboards have the GPU here. So the GPU was supposed to be here. This was the dedicated GPU. And then its own memory was supposed to be here. So these are the VRAMs, the video random access memory for the CPU. So sometimes you find if the issues from the RAM and then the GPU is not lucky, you find that these ones are shorted. So with this dedicated GPU, it is possible if this one is having the issue, if the GPU is having the issue, it is possible to have that laptop powers on again by doing what? By removing by disabling or doing away with the GPU so that the laptop to shift from dedicated CPU and then use only integrated GPU which is found inside the CPU. Disabling this, I'll discuss that in my other videos, but there's a process. In case you find that the laptop have dedicated GPU and then the GPU is the issue, you could disable that GPU and then have the laptop works only on integrated. However, the quality of images will have to downgrade. Why? Because you will no longer be using dedicated GPU. You'll be using integrated GPU, which is a lower performer or a lower performance than the dedicated. Now, let us now test. How do you know that the CPU is faulty and or the PCH is faulty? I am going to show you all the methods which are used to identify the problem if it is with the PCH or if it is with the CPU. Number one, the first one is to do what's called the physical inspection. You know, when you're cleaning up during the inspection, you have to clean the thermal paste because sometimes you find the CPUs have the thermal paste. Make sure the thermal paste is clean. The CPU is spotlessly clean. And how do you clean? Just have a tissue, a piece of tissue, wipe the paste until it is so clean, like this one, shiny clean. And then peek in, do the observation, try to check, observe clearly, try to see whether you can see any physical crack. Sometimes we find there's some cracks here, or a very small band at a tiny corner somewhere within the PCH or within the CPU. Same case applies to the GPUs or the north bridge and the south bridge. So do what's called the physical inspection. Once you're through that, and let's say you didn't see any crack or any burnt layer or anything wrong with the CPU, the next thing to do is to inspect the components supplying that CPU with power, like these ones, especially these MOSFETs. These MOSFETs, sometimes you find them, they got burnt, and then once they are burnt, it will short. Once they are shorted, you find that it will release the power from the main power lane. It will pass them all the way to the CPU. As you can see, let me just use a tool that will pinpoint whatever I would like to discuss. You can see this power supply, these two of them. The output is this inductor, and then the output of this inductor are conjoined together, and it went directly below this CPU, meaning these two chips, these two lines carries power to the CPU. Another one is this one. This one also carries power inside the CPU. So sometimes when you find these components are blown up, most of the time you find that the short is sent directly to the CPU, and then the CPUs get shorted. Another power for the solid bridge, you could see this one. The output of this goes inside this way, and then inside the CPU. So physical inspection, number one, if you can see any crack there, then also focus on this component supplies power to the CPU. Number two, once you've seen the physical inspection and there is nothing you could see, the next thing is to do what's called the measurement. I want you to use your digital multimeter to test uh, the resistance of the CPU with these inductors. Measure these inductors against the ground. Make sure your digital multimeter is in continuity mode. Your digital multimeter is in continuity mode. Make sure it is on. My continuity mode, I could either use the mega ohms resistance because I want to read the resistance, or I could use the beeping mode because from here I can also see the resistance. Because it is having resistance from the CPU, you could find that it always beeps. These inductors always beeps against the ground. However, what matters is the readings. What matters is the readings. Let us see. So black probe to the ground. Actually, it doesn't matter whichever the probe you use, because what we are after is the readings, the resistance, the peeping. Now, this one carries power to the PCH. Let's see. Peeping, you can see the readings is 29 ohms. If it was having an issue, I would have had readings which are below 5 ohms. Let's say 2 ohms, 1 ohms. It could have been a problem because there should be some resistance from the CPU. That's why it is peeping with some readings. What about this one? This one also is good. You could see it's having 43 ohms, which is very good. This one also 42 ohms, which is very good. This one 103 ohms, which is also very good. Now, because this one didn't peep, meaning it will not be, maybe it's not supplying power to the CPU. Let's assume we measure and then we find that it is having 0 ohms, or it is having measurements which are the same as for the ground. Can you see grounds against the ground? We have like 1.1 ohms, 0. That is 0.9. It's 1.0, 0.9 ohms, 0. You can see the reading is coming almost to 0. That is 0. So long as it is point or 1 point below 1.5, that is 0. In case I will have had readings which are close to that, it will mean that CPU is dead, whatever that line is going. So if it was this one, it will mean whichever this line is going, it is having a short. However, that's not enough to conclude that the CPU is dead. That's not enough. Measuring that alone is not enough. So once you have that readings, let's say you have the readings to be 0. Let's assume this one was supposed to be 0. Let's say we had 0.2 or 1.1 or 1.0 or 0.9. So our next thing to do is also to measure this one because they are conjoined. The outputs are joined here. Then it is sent directly one place. I was supposed to remove this inductor, remove this inductor. Once I have these inductors out, I will create the bridge. There will be separation between this IC and the other side because this inductors is what join this side to the other side. In between here, there's a gap. Once I remove, will see there's a gap between this side to the other side. I think I have also a motherboard whereby the inductor has been removed. Here, this motherboard, it was supposed to have an inductor here. Let's use this one for example. Can you see this? So between here, there was supposed to be an inductor which joined this side to this side. There's this line. These are two lines which send the current coming in and the current going out. You can see this side. There was a cap. There's a cap. Inductor joined this point to the other side. Here is another one. You can see also here. There was supposed to be another inductor here. This point was supposed to be joined to the other side. Here there's a cap in between. So what you will do with inductors like that, where are we? We were discussing this motherboard. When you remove this inductor, you will find that there was supposed to be this input line and then the output. Remove this one also, we have input now. Then from there, you will have to test now to find out that low resistance is it coming from this input or the output. If the low resistance, if this side is 0 and then this other side is now reading 40 ohms, it will mean the CPU is not shorted. Whatever is shorting that line is from this other side because at this side you will find that it is having 0 ohms or 1 point or 0.9 low resistance. It will mean the short is from the input line. That one you are lucky because you will only have to change one of these MOSFETs, or whichever the MOSFET is shorted. If it is this line, you will find that this one is the issue. If it is this line, you find that this one is the issue. But so long as the inductors are hit together and you find that from this side they are joined, you will always find the resistance from here is equal to the resistance from here. But when you remove them, you will separate this point to the other side. Then you will be able to determine whether the short is from input or the output. And this one applies to all the motherboards. Same case applies to this one. If here was having 0 ohm, you will remove this inductor and then find out whether the short is from the input or the output. If the short is coming from the output, yeah, that is bad news because it will mean that short is coming from the CPU. There's no way the short from the main power went through this line and then it spared the PCH. Nonetheless, it is miracle. And I know sometimes by the way miracles happens. So that is how you determine the CPU. It is shorted by measurements. We've said physical inspection, check whether there's any crack, any hole, anything burnt with the CPU or with these drivers. Number two, after you check, you find out there's, the first one, once there's a crack, obvious, there's nothing you can do about that. Then number two, maybe there's no crack, then you find there's something, yeah, maybe there's a punch MOSFET. So what you need to do to find out the short from that line, whether it is the issue is only the MOSFET or the issue has been passed to the CPU. When the issue is only the MOSFET, you are lucky because you'll only have to replace that MOSFET and then the laptop is on and live. Then another way to test that the CPU is faulty is by feeling it. Maybe before we discuss that feeling it, if you have thermal camera, that will be the best. Okay, me, I haven't bought one yet, but I'll buy it very soon. It's very important, though. Very, very important to have it because it will help you a lot. Because if you don't have, you'll have to work traditional way, like myself. I don't like though, but I'll have to buy one. This traditional way, very risky. Traditional way is so long as you don't have the short in the main power line and you're sure the power enters into the CPU, you have to plug into your power into your laptop And it is good to work the power supply because you'd be able to regulate the amount of current which goes into the motherboard. If you don't have, and then you plug in direct from the charger, it will be very big risk for you and your motherboard. I said for you and your motherboard. I started with you because if you got burnt, I don't know how you will continue repairing, helping other people. But if the motherboard got burnt, at least you will buy another one. You don't, there is no spare part for yourself. So once you're burnt, you're burnt. But the motherboard, when it is burnt, you have to buy another motherboard. Anyway, so you have to regulate the amount of current going to that motherboard, plug in the power, then try to feel. Try to feel with your hand. But you need to be very careful. You don't just touch it anyhow. You just have to tap a little bit until you feel like there's a heat. Then not just this way. It will burn you. It will be like you're trying to touch the hot substance. Just have to tap a little bit when you feel. When you hear it's not too hot, you can now have confidence and then try to feel it. And then again, you find the heat is emanating from the CPU. Then you have to find out whether is it the evenly distributed within the CPU or it's at certain point. Once you have heat emanating from a corner or somewhere, it also means that CPU is dead. And then here, when you find out this one is hotter than this, still that one is dead. This one is not supposed to be hotter than the other one because this one is not processing anything. It only ensures the communication between this and that, and also controls the input. So meaning it should not have any heat. The only heat we always feel from here is what is dispersed from the CPU because here is when you have all processes happening. Are we getting each other? Yes. And this one you need to be very careful because if the CPU decides to hit, it is very hard. The normal hot of the CPU, at least you can have your finger there for some time until you feel like it's really hot. That's a normal heat. And then again, the heat is evenly distributed, not concentrated in one point. If you find the heat is concentrated in one point, still that CPU is there. Because sometimes you find a heat is concentrated, and within inside here, this is like a micro motherboard. So inside we have other components like micro diodes, micro capacitors. So those components within the CPU, when they get shorted, you will find that the short is emanating from a specific area. You find that is getting hot from a specific area. Another thing, sometimes you find that the heat comes and goes. It comes after a few seconds, it become cold. Then if you still remain there, you'll feel like it's pinching you, and that also means there is a problem. Then we also have sometimes when the CPU is dead, but it is cold. Yes, you could also have a cold CPU. That one, sometimes it is something simple, sometimes it is not simple. The CPU, when it is cold, it will mean there's some power not reaching the CPU, or also it could be having the cold joints. We have what's called the cold joints. The cold joints is when you find the solder balls below the CPU are cracked. They are cracked. That is the only time when you can hit the CPU with hot air. But now it's not hitting anyhow. There's a regulated heat up of the CPU, whereby you manage the amount of heat you hit in the CPU until the solder bolts rejoins together, and then the laptop is able to come back to life. Most of the cold joints issues happens with these laptops which normally overheat, especially the gaming laptops, the laptops with the GPUs like this one, with the AMD processors, and the laptops, these ones for the latest generation, be 13 gen, 12 gen, 11 gen, most of them, when they operate, it will always melt the solder bolts, and then you find that when the laptop is not on, the solder bolts get cracked or get cold joints. Now that is it. So we verify this one. This one is good. This GPU is good. Let us let us see this one whether it's good or not. The inductors for the CPU, you can see this one is coming directly to the CPU, so meaning this is the inductor for the CPU. We also have these black ones. which I believe also connects to the CPU through the back. So let us measure. Let us measure and see whether it will. Let us measure and see whether they have what, whether they are shorted or not. Make sure your meter is in continuity mode, ground, and then here you can see the CPU. This one is having 7.6 ohms, which is good. What about from here? This one, 3.0 ohms, 2.7. It's also good. But once it reaches below 1 ohms, that is very bad news. Let's say below 1.5, it will become bad news. Here, same as these ones, and these ones are the same. So meaning they carry power to the same location. That is it. That one is good. Also, the CPU for this one is good. We're going to measure all of them. So let us see this one. Ground. And then the output is here. This one is showing 6.0, 5.9, which is good. And this one is going to the CPU, which is very good. This one, 4.2, which is good. This one, 4.2, which is good. So these ones are joined, they are together. Then we also have an inductor here. There was supposed to be an IC. I don't know whether you could see it. When I bring it closer, you can see there was a burnt IC here. There's a chip which got burnt here. This was supposed to be BD controller like this one. Can you see this? There was supposed to be BD controller here. And then there's supposed to be an inductor here. So let us see. So let us see. Maybe this CPU got faulty because of this inductor which was removed. Maybe whoever was repairing this, because this was not me. Yeah? This was not me. Let us see. There was supposed to be an inductor here. So there was supposed to be, this was supposed to be the input. Oh, my meter is off. So let us see. It said there was supposed to be what? Let me put it down this way so that we can see together. Like us to see together. Here, I believe this was supposed to be input. The input, 0 ohms, meaning from this side there is no short. What about the output? The output is also having no issue. You can see, even the output has no issue. But now this IC which you got burnt here, it actually blows the motherboard layers. So maybe that's why this one was beyond repair. Remember, as you were starting, I said sometime you find an IC or a chipset which got burnt, or the level of destruction is too much. Until when you consider the amount of work needed for that motherboard to operate, we have to consider how much work you have to work, and what is the outcomes. Is it guaranteed after you repair it will work forever, or it will work for a long time? You have to consider those factors. Sometimes it take long time to repair a motherboard, and then in the next 2 weeks or in the next 1 week, the same motherboard is dead again. That you'll keep on doing the warranty thing. So sometimes it's better again to give the customer honest suggestion. Analyze the extent of damage. If the issue is too bad, just have to do away with it. Just have to tell the customer this one is beyond repair. The better solution for this is the motherboard repair. And again, I don't advise you to be lazy. Before you say this one is beyond repair, just see whether it is something you can fix. But again, as a technician, also you have to consider your time. It's always business. I know the bottom line, we are after helping customers. We are after satisfying our clients. But sometimes also you have to consider how much work you have to work. And after you work, can it last long time? If it lasts long time, it's also your duty to tell the customer, yes, I can fix this. However, I cannot guarantee you it will work for more than 6 months. It might get damaged again. Most of the a good example is when you have a laptop with spillage. You have to check the extent of corrosion in the motherboard. Is it things which can come again in few weeks, or is it things which you can fix once and it is fixed? These cases of corrosion, most of the time you find that we analyze, we inspect the motherboard, we see the extent of damage. If it is something big, it will not be necessary for you to fix that. You just have to recommend the customer to change the motherboard. Now, so this one is a CPU also is good for this one, because you can see the power supply for the CPU having no resistance. It will mean the CPU is good. This one, yeah. So let us also have this one. This is the data G3. We said it should have some resistance. The CPU should have some resistance. Ground. And then we have the power supplies. We measure the power supplies for the CPU. You see this one, 8.0, which is very good. I am not supposed to have zero like this one. Here is the ground. You can see the ground is reading 1.5. That tells you that's the ground. So if the positive line is reading the same value as the ground, it is a problem. But you can see this one is peeping at 11 ohms, which is very good. This one, 11 ohms, very good. This one, 7.8, good. This one, 7.8, good. That is it. The rest of the power supplies are not for the CPU. That's why they have unlimited resistance. That's 124 ohms. This one, open line. This one, open line. You can see these auto inductors are not connected to the ground. Why? Because they're supplying power. They're not supposed to connect to the ground. But these ones, they are not connected to the ground, but they do have resistance from the CPU. That's why you can see it is reading 7.5. But when you measure the ground side of this line, it's having 1.5, which tells you that one is the ground. You see the grounds, what is the resistance of the ground? 1.5, you see? See this one also, the CPU is good. And then let's see this one. This is the GPU. Yeah, okay, this is the CPU. Sorry, this is the CPU. However, this is AMD CPU. So let's see the resistance. There's something I want you to know about these AMD CPUs. These ones, they do have lower resistance as compared to the Intel CPUs. Yeah, so this one you find out they do have like 1.5 ohms. So first, let us check the baseline, the grounding. The grounding is 2.3, no, 0, somewhere there, 1.5. So that's the ground. That's the ground. So once you find the resistance from the AMD coming closer to that, it will mean that CPU is dead. But if it will have slight higher than that, it will mean that CPU is good. So let us see the positive. This one is reading 31 ohms, even though it is beeping, but it is reading 31 ohms, meaning it is good. There's also have another power supply for the GPU. I believe they are this one. Really? Not this one. Where are they? This one 22 ohms. So this is one of them. And then I believe these are the others. These are the others. 30 ohms. 30 ohms. You could see most of the time you have several power supplies towards the CPU. Why? Because inside the CPUs we have the node bridge, the software bridge, the CPUs have the GPUs, all those. So my guys, do you have any question? Because I believe right now I met your expectation. I always get a lot of requests for me to do a video on how to measure the CPUs, and I believe today I did that. Nonetheless, you have any question, I do welcome your question in the comment section. I'll answer you either directly on the comment section, or I'll consider making a video answering your question. Otherwise, I'm very happy. And please, guys, I'm still requesting you, my guys, please. In case you haven't subscribed to our channel, I am asking you, humbly requesting you to subscribe. Give us some comments and share this video with your friends who are interested in learning about the laptop repairs. And in case you're interested in learning too, you're highly welcome to our classes. We do offer courses both online and offline. So whichever the module you're interested in, you can just contact me that we discuss the way forward. Again, in case you're having an issue with your laptop, please do not hesitate. Yeah, or if you know somebody having a problem with this or a laptop, do not hesitate to refer them to us. Recommend them for us. We offer the best services. Thank you so much, guys. Do not forget to subscribe and see you in the next video. Goodbye.